Okay, so let's start with our syllabus. So today we are going to see non-exact differential equations. Uh, the definition for exact differential equation m dx plus n dy is that partial derivative of m with respect to x, m with respect to y is equal to partial derivative of n with respect to x for the differential equation m dx plus n dy equal to 0. For this differential equation, if this condition holds, then we say that this differential equation is exact. The basic definition for a differential equation being exact is that the given differential equation is derivative of something. So today what we need to see is non-exact. What do we mean by non-exact differential equation? Is a differential equation m dx plus n dy equal to 0 is non-exact if partial derivative of m with respect to x is not m with respect to y is not equal to partial derivative of n with respect to x. If these two things are not equal, then we say that it is non-exact. So before going to the further terminology, I will write down a differential equation which says that y into dx minus x into dy equal to 0. So what is the value of m here? M is y, n is minus x, partial derivative of m with respect to y is equal to 1, partial derivative of n with respect to x is minus 1. Both of these are not equal, so this differential equation is non-exact. Can you identify a function whose derivative can be this? Can be this, I said, by making some proper changes.
X by Y.
Derivative of x by y, but you will
By
have to
Y.
make some change over there.
So we'll divide by Y square.
Divide by y square on both the sides. So if we divide, or can I say multiply? Multiply
Multiply
by
by 1 by Y square.
1 by y square on both sides. So this will become y into dx minus x into dy divided by y square. 0 by y square is actually 0. So this term now becomes the derivative of x by y. Now if you see what will be m in this new differential equation, this I will consider a new differential equation after multiplying by 1 by y square. M dash I will call it. What is m dash? Is 1 upon y if you separate the denominator. What is n dash? N dash is nothing but minus x by y square. Now if you check, this will become exact. Now this has become exact. Okay, you can check it from this. This will be minus 1 by y square, and derivative of n with respect to x is minus 1 by y square. So this has become exact by multiplying 1 by y square. So this is a factor by which you multiply and your differential equation converts to exact. Okay. So this is called the integrating factor. This is called integrating factor. So a non-exact differential equation can be converted to exact differential equation by multiplying a function, and that function is called integrating factor. So the next definition that I'll write it down, and our complete task will be revolving around finding this integrating factor, because we know once we get the integrating factor, we can find the solution by our previous formulas. So the integrating factor is a function, a function k of x comma y is said to be integrating factor is said to be integrating factor. Uh, it is abbreviated as I dot f of of the equation m dx plus n dy equal to 0. If after after multiplying the differential equation m dx plus n dy equal to 0, we get exact differential equation. So that is k times m dx plus k times n dy equal to 0 is exact. So what we will do is, first of all, we'll check whether it is exact or not. If it is exact, well and good. If it is not exact, then we'll find an integrating factor such that if I multiply by that integrating factor to the differential equation, the new differential equation is exact. And there are 4 rules to find this integrating factor. Actually, there are 5 rules, but in our syllabus we'll study 4 rules. Rule number 1. So rules to find integrating factor. The rule number 1. In each of the rule, what you will have to do is you will have to identify the differential equation of a certain form, and then we can declare the integrating factor. So if mx plus ny is not equal to 0, and the differential equation m dx plus n dy equal to 0 is homogeneous, is homogeneous. Is homogeneous, then the integrating factor is equal to 1 upon mx plus ny. Yes, can anyone tell me what is homogeneous differential equation?
in which the dependable and independent variable has same degree.
No.
सर जब x और y को लैम्बडा x और लैम्बडा y से रिप्लेस करके जो फॉर्म लाते हैं लैम्बडा टू द पावर n इंटू एफ ऑफ एक्स वाई, उसे
हाँ,
कहते हैं
उसे क्या कहते हैं?
मीन्स
होमोजेनियस फंक्शन कहते हैं.
हाँ.
आई एम आस्किंग होमोजेनियस डिफरेंशियल इक्वेशन. विशाल,
Yes, sir.
what is homogeneous differential equation?
Sir, actually, they are the differential equations having the functions of same degree.
Which functions are having the same degree? Or Sahil? Yes, Sumed?
Sir, M and N has to be of should have same degree.
Yes, very good. So, differential equations in which m and n are homogeneous and both are of same degree. So, in that case, what you will say is that particular differential equation is homogeneous. Okay. So, a function being homogeneous is a different story, and a differential equation being homogeneous is a different story. So, a differential equation is homogeneous if and only if those coefficients functions are homogeneous and are of same degree. So in that case, we will have the integrating factor equal to 1 upon mx plus ny. Rule number 2 says that if mx minus ny not equal to 0 and the differential equation is of the form y into f1 of x into y dx plus x into f2 of x into y dy equal to 0, then the integrating factor is equal to 1 upon mx minus ny. Can anyone try to explain this form, what it says? Yes, Utkarsh, can you try? Utkarsh Kumar.
No.
No. No one. You have the form given over there. You just have to explain it.
So it's just showing the form now. If we are
Yes.
having a function of xy in the first term and also a function of xy in the
What do we mean by function of xy?
it means it's containing both x and y in it.
No, that's the same thing for f of x comma y. Then why it is xy?
Mm. Then it must be a function of x
Sir,
into
it is implicit function.
Yes.
A function of xy is implicit, which means it cannot be separated.
No.
then it must be having product of xy.
It should be.
Some of
Can you
with
give an
X
example?
and
Okay. Let's leave everything and can you make some example where you will have f of xy?
Okay.
Chirag Agarwal.
yes, sir.
Yes. Can you tell me a function of xy?
So we can take any function like
Yes. Give me
xy
any
to the
example.
whole square plus xy is also a function of fxy.
Yes. Tell me.
Like x into y whole power whole power 2 plus xy.
Plus xy.
Yes,
Okay.
it's a function of
So
x.
yes, it is exactly right. So when I say f1 of xy, it means that variable wherever the variable will occur, it has to be in the form of x into y. It means that in the complete expression, I can replace by xy by m, and you will get a function in terms of m. So when I write x into y, xy, it means that in that function, wherever the variables are occurring, they are occurring in the form of x into y. So f of xy is equal to x plus y. Is it correct?
Sir, matlab XY will be treated as a single variable there and function of
Yes.
XY.
Yes. So
So sir, we can say it like
Mohit, wait,
one.
we shall wait.
Okay.
Mohit,
Yes, sir.
yes, is it correct? F of xy is equal to x plus y?
No, sir.
No. Yes. So this is not in our case. So our case deals with I can take y outside and totally I will get a function of x into y. In the second one, I can take x outside and totally I will get a function of xy. So such type of differential equation and this type of differential equations, what I need to do is the integrating factor will actually be equal to 1 upon mx minus my. So I hope the rule is clear to you now. So I'll go to the last rule. These are actually two rules, but I will combine it for better understanding. So rule number 3. If for a differential equation m dx plus n dy is equal to 0, 1 upon n partial derivative of m with respect to y minus partial derivative of n with respect to x divided by not m divided by n first. Divided by n becomes a function of x, then integrating factor is equal to e to the power integration f of x dx, or 1 upon m partial derivative of m with respect to y minus partial derivative of n with respect to x is equal to g of y. Then integrating factor is equal to e to the power integration g of y dy minus. So I will summarize everything. So if a differential equation is homogeneous, then my integrating factor is 1 upon mx plus ny. If my differential equation turns out to be in the form of x into y, okay, then my integrating factor is 1 upon mx minus ny. So if both the cases does not occur, okay, so it is not homogeneous, it is not in the form of x into y, then I will have to go for rule number 3. What does the rule number 3 say? Look at both the things. You are taking the difference. What difference you are taking? Partial derivative of m with respect to y minus partial derivative of n with respect to x. So I will look at the difference of these two. And then I will see if after dividing by n, I am getting a function of n क्या है dy का coefficient. If by dividing by the coefficient of dy, I get a function of x, then what is the integrating factor? E to the power integration f of x dx. If after dividing by y, then I am getting a function of y, then what is my integrating factor? E to the power minus integration g of y dy. Note it down somewhere, all three rules, so that I can go for examples. And if you have any difficulty, you can ask. So I think no. So example number 1. Solve xy minus 2y square and dx minus x square minus 3xy dy equal to 0. So what is m here? M is xy minus 2y square. What is n? N is minus of x square plus 3xy. A partial derivative of m with respect to y is equal to, that is x minus 4y partial derivative of n with respect to x is equal to minus 2x plus 3y. These both are not equal. So given differential equation is non-exact. Once we declare that it is non-exact, what I have to go for? Go for finding integrating factor so that it becomes exact. Which rule will be applicable here?
Both are having same degree.
So m and n both are having same degree. So note that the differential equation is homogeneous. So when differential equation is homogeneous, so integrating factor is equal to 1 upon mx plus ny. Am I right?
Yes, sir.
So we'll find out the integrating factor. Integrating factor is equal to 1 upon x into xy minus 2y square plus y into the value of n, which is minus x square plus 3xy. So if we simplify this, we'll get x square y in the first term, x square y in the second one. Both of them will get cancelled out. So minus 2xy square plus 3xy square. So integrating factor is 1 upon xy square. Please check the calculations again. Yeah, it is correct. So we have got the integrating factor. What is the use of integrating factor? When we multiply our differential equation by this integrating factor, my differential equation will become exact. So multiplying by integrating factor, we get xy minus 2y square divided by xy square dx minus x square minus 3xy divided by xy square dy equal to 0. This can be further simplified as 1 upon y minus 2 by x dx minus, in the first one I'll get x by y square minus 3 by y dy equal to 0. So now after multiplying this, if you want to check whether your integrating factor is correct or not, what you can do is take the partial derivative of this with respect to y, take the partial derivative of this with respect to x, and you will see that both of them are equal. So this, after multiplying, surely you will get an exact. So the solution of this is given by solution is given by, what is the formula? Integration
mdx keeping y constant
mdx keeping y constant
plus integration of
terms of n
terms of
free
n
from
free from x.
x. So that is just
Dy.
one term, which is 3 by y. So integrate this. So we'll get x by y minus 2 log x. So I'll write it down here at the top right corner. So the solution here will be x by y minus 2, the integration of 1 upon x, which is log x. Integration of 1 upon y is log y equal to c. This is the final solution.
So does the base of the law matter?
Yes,
Does the base of the law
log
matter while writing, sir?
whenever you are integrating, your base will always be e. Fine.
Yes, sir.
Next example. Solve x square y minus 2 x y square dx minus x cube minus 3 x square y dy equal to 0. Please do it. And this is the same, I guess. Wait. Let's change.
Same.
Is it
Not
same?
same. Not same.
Okay, I'll change it.
Sir, previous slide can you please?
Let me just write down the question. 3 x y square minus y cube dx plus x y square minus 2 x square y dy equal to 0. Tell me now, what previous slide?
Sir, previous slide I have to write, sir. Yes. Okay, sir.
Yes. Try this question, everyone. Tell me what is the integrating factor. Give me the final solution. I've given the form. Please put up your attendance as well. What is the integrating factor, others?
1 upon x square y square.
1 upon x square y square. Yes, correct. The solution.
Sir, is it 3x plus y by x minus 2 log y?
3.
3x plus y by x plus minus 2 log y.
What I have is okay. Well, let's wait for some time. I think you're correct, but it will need some simplification actually.
Okay, sir.
I'll wait for some time if someone else can get something. Ping Paramveer.
Yes, sir. Give me a second.
What is the solution? Sunidhi Gupta.
Yes, sir.
What is the solution?
Yes, I'm just doing 1 minute, sir.
Sir, is it x by y minus 2 log x plus 3 log y is equal to c?
X by y minus
It is
2 log x plus 3 log y.
yes.
Yes, sir.
The same solution.
Yes, that's correct. So that can be simplified to this form also. So it is c into y square upon x cube is equal to e to the power y by x. Fine. So that's it for today. In the next lecture, we'll end this non-exact also. Please be prepared for this. Yes,
Sir, can you repeat the solution?
I've written it on the screen.